The METUS Tech Show.
Welcome to the METUS Tech Show, a show for HVAC professionals by HVAC professionals.
The METUS Tech Show.
All right. Yeah. When's the last time you had a good breakfast, Paul?
I haven't had a
Like
really decent breakfast in a long time. Typically, lately I skip breakfast. I just wait till late morning or wait just for lunch before I eat anything. But breakfast, I love saying that breakfast is the most important meal of the day, and sometimes I have two.
Yeah. I'm like really into a huge breakfast sometimes, like on a weekend, go to a diner or just a little breakfast joint nearby and get my favorite's got to be steak and eggs.
Yeah.
Just a little sirloin, eggs, home fries, toast, the whole 9 yards. One place in particular is North Conway, New Hampshire, right next to Storyland amusement park. There's a breakfast restaurant there that is pretty famous. When you go in, there's a model train that runs the whole length of the inside of the restaurant that just goes around the whole perimeter, and my kids love it. But my favorite there is steak and eggs with baked beans.
What?
I know it sounds crazy, but I'll tell you, steak, eggs, a little side of baked beans, just regular baked beans, nothing special, maybe a little bacon in it. That whole combination is just unbelievable. And with the Texas toast, it's like my favorite meal. I'll make breakfast for dinner sometimes for the kids.
I love breakfast. The first breakfast I ever made for my wife, I didn't know what she wanted. So I made everything. I made eggs, I made bacon, I had sausages, I made pancakes, I made waffles, I had coffee.
It's a lot of work.
Yeah, it's a lot of work, but it's my favorite thing to cook. Now, my breakfast when I was single, right, I would take a pound of bacon and I would fry the whole pound of bacon. And then in the bacon grease, to get it nice and hot, and I would fry the eggs. So the outside of the eggs get nice and crispy. And then I take a big spoon and you splash the oil on top of the egg, so it's like over easy, but you don't actually flip them over. And then I would take those eggs, and then I would take half of an Italian bread, right? I would cut it in half, and then I would cut it crosswise and make a sandwich. And then I would put the 3 eggs and the whole pound of bacon and a couple of slices of cheese in that. So I would have half of an Italian bread, bacon, egg, and cheese sandwich. I made that once for my wife. And she said, "You are never allowed to make this breakfast again."
Yeah, with a side of statin prescription cholesterol meds.
I tell you what, back when I had a motorcycle, I used to go for rides out through Central Mass, and we go to Oxford, which is just south of Worcester, in this Carl's Diner, and he had some crazy omelets. I mean, these things were huge. If you left there hungry, you got a problem. If you could finish everything that he gave you, which I usually did, then you got a problem. Right, but it was so good. But I love breakfast. I love going out for breakfast. There's a place near my house in Lancaster, Mass. It's a Michael's Bridge Diner. They got all these. The guy's a hunter, so he's got all these stuffed bears in there, but the breakfast is wicked good. He's got eggs Benedict, but you can get it with brisket. You can get it with these thick pieces of ham. You can get it with what's that one I hate? Corned beef hash. Can't stand that. But anyway.
Well, there's a diner right up the street from me that makes linguiça hash.
That sounds good.
All right.
That sounds really good.
It's ground linguiça hash, and it's actually my niece's husband bought half the restaurant and is the cook there. That's one of his signature recipes, and it is out of this world. It's amazing. And I'm going to redeem myself because a couple episodes ago I forgot about the name of the restaurant in Orlando where I said the portions are gigantic. Is called the Hash House A Go-Go.
Oh yeah,
I'm going to Orlando. I'm going to Orlando next week. Is that a breakfast place?
It closed. I found out it closed in Orlando. Now, there's one in Mohegan Sun that when we used to play shows there with my band, after we were done playing, it was like 2 a.m. We'd go over to the Hash House of Go-Go and get a gigantic breakfast. And I'm telling you, the waiter comes to the table at this place, whether you're there for breakfast or lunch or dinner, and they tell you our portions are gigantic. So be ready. And it's the prices are actually really good for the size of the portions they give you. But the breakfasts are just out of this world. Gigantic 4-egg omelet. It just amazing place. But my favorite go-to for breakfast is got to be a Greasy Spoon Diner.
Yep.
I don't care what it looks like. It's probably going to put out the best breakfast for
it. It's a little hole in the wall, nothing fancy. It's just those are the best places. I love breakfast, and I agree with you. You can have breakfast for lunch. You can have breakfast for any time. I've had breakfast at 3:00 in the morning. I get hungry. I'm going to fry me up some eggs and some linguiça and with bacon. I'm ready to go.
So and I'm going to pay homage to Gary in New Jersey, because I remember we took a trip, Paul. This is before Gary worked for us. We took a trip to inspect some training centers in New Jersey and stopped at a breakfast place. And on the menu, I look and I see pork roll. And curiosity got the best of me. I had to ask the waitress, "What is this pork roll?" And she said, "You never had pork roll before? It's big in New Jersey." Yeah, well, I'll take it. It's bologna.
Yeah.
It's a big, thick slice of bologna.
Fried bologna is what it reminded me of. Yep.
But nothing beats fried bologna with eggs. I mean,
the thing about bologna, when you eat bologna all day long, you know you ate bologna.
Yeah, pretty much. Yeah, you got to slice them too before you fry them. You got to put a slice in there so they don't bubble up. Yeah, it's important. Yep. Important stuff.
Oh yeah.
So right down the street from my house, I have a place called Shady Glen. And that's
called what?
Shady Glen.
Shady Glen.
Yeah. Okay. And it's been there. Okay.
Sounded like you said something else.
Gary.
Why would you eat there?
Woodard. So it has been there forever, and they haven't updated a single thing. The diner tables are still yellow, and it's awesome. It's one of those greasy spoon diners. Yeah. But the last time I went to Newport, we went to a place called Crew Cafe. And that's more like an upscale breakfast place, and it was awesome. It was so good. I mean, I still got the basics, bacon, toast. I avoided the eggs.
You don't like eggs?
No.
It's not normal.
But it was phenomenal. They had a huge menu and the speed that it came out. So it's kind of cafe style. You go up to the counter, you order your food, and you go find a table. And by the time we sat down and got settled, the food was already out. I mean, it was insane.
Bryn, you actually have something in common with one of my mother-in-laws. You don't like eggs. She doesn't like eggs. And she's a nice person, but a little off.
Yeah. Well,
cooking breakfast is so much work to get it out where it doesn't get cold. Yep. And, just being the cook. I cooked at Newport Creamery for 3 years as the line cook for breakfast on the weekends. And Sunday, everybody coming out of church. You got all the old people coming in with no taste buds, and they're sending food back left and right. The eggs are runny. The eggs are overcooked. It was hell on earth.
We're gonna get emails. Breakfast. We're gonna get emails from old people now because of this.
Yep.
Yeah, we're old people.
Yeah, I know.
So
I'm older than you.
We're getting there. Yep. Anyway, welcome to the METUS Tech Show, everybody.
All right. So, what are we going to talk about today?
We're going to talk about branch boxes, all types of branch boxes, residential, commercial, new branch boxes.
Get your
new
branch
hybrid
boxes here. We got branch boxes here.
Yeah, the new hybrid branch box. We'll even touch on that a little bit. But let's start with the basics. Let's start with residential branch boxes.
Okay. So which units, before we go there, which units have branch boxes? Which systems, I should say, have branch boxes?
Just one, our smart multi system.
Okay, on the residential side, it's smart multi, and on the commercial side, it's either the R2 or the hybrid VRF. They have branch boxes, and I like your idea. Let's talk about the smart multi first. So, smart multi, for those of you who don't know, come in two flavors, either with a branch box or without a branch box. with the branch box using M and P series indoor units, without a branch box using City Multi indoor units. All right. So what is a branch box?
Basically, it's just distribution for different indoor units. It's a distribution box that houses LEVs on the residential side and some thermistors and some circuitry. And we're distributing refrigerant to different indoor units. And it may be on the Smart Multi, one branch box or two branch boxes.
All right. Yep. So from the outdoor unit, I've got my high side and low side refrigerant pipes. And if I can go into a branch box, for my connections there. And if I have two branch boxes, and how do I connect them?
Basically teeing off the first branch box and running right over to the second branch box.
So just tee off before I head in and feed both branch boxes, right? So let's talk about, so we have the connections, the refrigerant comes in, and then what happens?
Well, if we're talking residential,
that's what we're doing.
Yeah. So residential, essentially, it's like Steve said, it's just a box, distribution box. So we have the ability to connect, multiple indoor units to that one branch box. It's a series of LEVs in there. Remember, with our residential heads, they're powered off of that branch box. So they don't have an LEV inside of them. The LEV actually exists inside that branch box. So we don't have the mixed modes like we would with a VRF system or a heat recovery system.
Right. So the whole system on a Smart Multi, the whole system is in heat or the whole system is in cool. We can't have mixed modes like you said.
Yep.
So what sizes do these come in as far as how many ports?
So you can have a 5-port branch box, and then we also have 3-port branch boxes.
Okay.
And as far as total capacity goes, if we're using 208, 230 single phase, we can get up to 60,000 BTUs, and we just came out with our 6, 8, and 10 ton. And that's a 3-phase unit.
All right. And the branch box for that, is it fed the power, electrical power? Is that fed from the indoor unit on a separate circuit? How do we do that?
Well, you get your choice, right? So with our Smart Multis, we have that B1, B2 terminal block, and we can actually power our indoor units from the or our branch box, from the outdoor unit.
And that just brings 208 single phase to the branch box?
Yep.
And if we wanted to, we could power that branch box from a separate 208 single phase circuit.
Exactly.
All right. So back to the branch box itself, it's going to have some LEVs, and it's going to have an expansion valve for the indoor units.
Yep.
Right. So if I got a 5-port, there are 5 LEVs in there.
Correct.
All right. And then there are thermistors. So where are the thermistors and what do they do?
So our thermistors are basically measuring refrigerant temp coming out of the units or going into the units, depending on the mode we're in, heating or cooling.
Right,
so we're also measuring temperature in the branch box, not only in the indoor unit coils in and out, but in the branch box, we're measuring refrigerant temp in one direction.
All right. So 2 pipes coming in from the outdoor unit, and I should say, there's one set of 2 pipes coming in from the outdoor unit to the branch box, and then there's 3 or 5 sets of high and low side pipes going to each indoor unit. Do I have to use all ports?
Nope.
No.
So
you can use whatever port you want too.
And
you don't have to start with port A. You can start on any port you would like for future expansion.
Yeah. And I recommend ball valves. I think ball valves are your friend. For isolation for later on, you should put ball valves. Even on the port you're not going to use, throw some ball valves on there. It may save you a big headache later on down the road.
Yeah,
right.
Those, especially once you get into the branch box world, whether it's residential or commercial, the ball valves, as far as troubleshooting goes, are super helpful.
And servicing later on too.
Yeah, I wouldn't even try to install one of those without them.
All right. So, Steve, you said I don't have to use all the ports, and I don't have to use port A. I can start with port B. And how does the unit know which port to open? Well, how does the branch box know which port to open?
So we have a set of dip switches, SW1 dip switch bank as 1 through 6. 6 is not used. We're basically using dip switches 1 through 5, and each dip switch is representing port A, port B, port C, and D, so on. And we flip that dip switch for whatever port is actively being used. Without flipping that dip switch, that port is not functioning.
Yep.
So that's really important.
All right. So that's good to know. All right. And then Anything else we need to know about the residential branch box for the Smart Multi with the with M&P indoor heads?
Yeah, so something interesting, like Brent mentioned, the new Smart Multi larger tonnage units, the 6 through 10 ton, 3-phase Smart Multis utilize multiple branch boxes, so we can put more branch boxes onto that system.
Yep.
So the smaller systems, the single phase ones, are up to 2 branch boxes, and I can put more than 2 branch boxes on the 3-phase. Can I still feed the power to the branch box with a single phase from the outdoor unit, or now does it have to be a separate circuit?
It can be whatever you want. You can use B1 and B2 terminals off of the outdoor unit if that works for you. I always tell contractors that wire's expensive, and if I'm going to be running a long runner wire to that branch box, maybe I can come off of the panel with its own dedicated circuit to the branch box. The branch box does not care where it gets its 208.
Yeah, that's
so.
Right. So if it's closer to the panel, it makes sense to just run a separate. If you got the room in the panel for another breaker, just run a separate circuit.
Right.
All right.
Yeah, a lot of questions I get too is about why not just use a ported unit as opposed to the branch box. And if you've ever built a system in Diamond System Builder, a ported versus a branch box system, that branch box gives you tons more line set. Without losing as much of the, we don't have as much of a D rate with those branch box systems. So,
because any refrigeration system that has piping attached to it, the longer you go with the piping, the more it's going to D rate, and that's just a law
the nature of the beast.
Physics or whatever you want to call it, thermodynamics. I don't know, but if more line, D rate, that's it.
Yeah. So those branch box systems, especially for larger houses, you can get ahead in every single room or every room that you need it, without having to sacrifice maybe outdoor space. Instead of having to have a couple outdoor units, you can kind of stick to that one. And
if I got a 4-port outdoor unit, I got 4 sets of lines going into the building now instead of just the 2 if I put a branch box.
Yep.
That makes sense.
Yep.
All right. So what other kind of questions do you guys get? Because I haven't taught that class in a while. So what are some of the questions that you get from contractors in class, and maybe we can share those, help somebody?
Yeah. I think the biggest question I get is how to address the Smart Multi-system.
That's a good one.
All right. Yeah. So, basically it's a little different than city multi-addressing and much simpler, but whatever address I give that branch box, the main branch box, or whatever I call the main branch box, whatever address, and it's going to be an address that falls in the range of an indoor unit 1 through 50.
Yep.
I can't exceed 50. I'm going to give that branch box an address of, let's say, 1, and whatever. So the outdoor unit is going to get an address based on that address 1. It's going to be plus 50. So if the branch box is 1, add 50 to that. That's the address for your outdoor unit, address 51.
I'm glad that you brought up addressing, because there's still a misconception out there, and I keep hearing this every so often. Well, I was told you don't have to address it, and that is not true. It has to be addressed. I know when we first released the Smart Multi with the branch box years ago, there were people that was saying I didn't address it and it works fine, but eventually there will be a problem. So yes, it must be addressed. So you address the outdoor unit, you address the branch box, but there are no dials at the indoor units on an M&P series. So how do we address the indoor units?
So
they auto address.
Yeah. So let's say you have 4 indoor coils on that branch box, and you give that branch box an address of 1.
Yep.
Your first port, let's say we use A, B, C, and D. Port A is going to automatically be assigned 1. It's going to assume the address of that branch box, and then it's just going to go in sequential order from there. So 1, 2, 3, and 4.
All right. Is it a good idea to skip a port? So can I use A and B and skip C and use D and E?
You can.
All right.
You just have to flip that SW1 dip switch in the branch box to activate that port.
Right. Yep. So in the addressing rules will still follow along. It'll be address 1 on A, and then 2 on B. It won't give an address to C, and then 3 on D, and 4, and so on.
Right.
All right.
And always address your Smart Multi system. No matter what anyone tells you, you can not address the system and it'll work. Yes, it'll work until it doesn't.
Okay.
Yeah.
So
Say that one a lot.
Yeah, let's talk about two more things about the branch box. The first question is there a condensate drain on that branch box?
no,
No. Okay, that's right.
it's well insulated. Quite a bit of insulation inside the branch box.
And the second question I have is what position can I put that branch box in? Can I mount it upside down, right side up, on the wall? What can I do? How can I mount that?
So with the residential branch box, we can mount it upside down, upright, depending on how you could possibly be putting it in an attic and hanging it from some threaded rod, possibly.
Or right
and that's what we recommend.
Right on the floor of an attic, where it could be. So there's a convertible panel to either mount it from the ceiling or mount it on a floor or so on. And can I mount it on a wall?
Absolutely.
And
yes.
What do I got to be careful of if I mount it on a wall?
All I got to do is make sure that my connections are facing down.
The connections for the outdoor unit.
Yes.
Yeah.
Connections for the outdoor unit are facing down. That's the only rule with mounting it on a wall.
Okay. And there's one other thing I want to mention, and I demonstrate this when I'm teaching when I used to teach the class. I have the power off, and then when I turn the power on to the outdoor unit, and that's feeding power to the branch box, the LEVs are now turning. And when they turn, there's a tiny little clicking to them. If you're not listening to it, you won't notice it. If it's noisy, you won't notice it. But be careful where you put that branch box. Steve, you mentioned an attic. If I put it in an attic right above a bedroom, it's not that the thing gets noisier at night. It's just at night, everything else is quieter. Mm-hmm. In my house, I have a digital thermostat, and I can hear the contacts clicking at night, turning on and off because everything is so quiet. There's no other time of the day when I'll hear. I could be right next to it in the middle of the day, and I'm not going to hear it. So the clicking of these LEVs, trying to find their position. If you put this in a closet or in an attic and they're near the bedrooms, that's just something to consider. So be careful doing that.
Yeah. Yep. The only other thing I would like to add when it comes to the residential smart multi is communication. Right. So generally with our residential line, we're using A control. We have S1, S2, S3. With that smart multi, our wiring to the branch box, our communication wiring is MNet. So if you've done anything with commercial, our MNet, it's a 16 2-stranded shielded wire, 29 volts DC constant. That's the communication between our outdoor unit and branch box. From that branch box, to our indoor heads, we go back to that A control. But just something to keep in mind if you are going to be installing is you need to get some control wire for that indoor to outdoor
and say the wire again for the MNet, because that's important.
Yeah, so MNet wire, we want to have 16 2-stranded shielded wire, and we want to make sure they're home runs. No splicing, no wire nuts, all that good stuff.
Right, and then S1, S2, S3 from the branch box to each indoor unit. Right. So what do I have to be careful of? I now have a branch box, and I have an outdoor unit that's going to a branch box. I'm running refrigerant lines, and I'm running electrical lines, and now I'm running MNet. Let's say I'm running the power from the outdoor unit. We'll stipulate that. So refrigerant lines, AC power, and then MNet from outdoor to the indoor. That's you can't screw that up. You can't connect the wires to the refrigerant, and so on.
Yeah, I mean, you definitely want to be careful of that. But
you want to land the wires in the right place.
Yeah, you definitely want to pay attention to that part of it. But the other thing to keep in mind too is that MNet can be sensitive to interference. So generally, some people will use that waterproof conduit to run inside, and we don't recommend keeping that MNet wire close or within the same conduit as your power wire, just because it does tend to induce interference.
I probably shouldn't say this because I'm not 100% positive, but I think electrical code doesn't allow you to run high and low voltage wires in the same conduit anyway. But if there's an electrician out there I doubt they're listening to this show anyway, they're probably saying, "Oh, this guy's wrong." But so let's go back. So you can screw it up if you try hard enough, But from the branch box to each indoor unit, now I'm running an S1, S2, S3 wire and the refrigerant line. So if I've got port A, and I've got my high and low side pipe going to unit A, and I've got now on the branch box on the board, there's also an electrical connection for port A. I want to make sure that I connect those in the right spot.
Oh, yeah.
Right? Because cross piping or cross wiring, whatever you want to call it, it's easy to do if you're not paying attention. So just make sure that if the indoor unit is electrically connected to port A on the board, that it should be mechanically connected to port B on the refrigeration. I'm sorry. See, I just cross-wired myself just now. You know?
Yeah. It's
How
like you
easy it
said,
is, but
it's an easy mistake to make,
yes,
and it's hard to find.
Yeah,
Yeah.
and I'm going to
Right,
talk about that. I'm going to talk about that. I'm probably going to give away some secrets here for people who come to the class. But one of the faults that I used to do that. I purposely switched the wires. So port, and I'm not sure what ports are. I'm just going to say it's port A wires are connected to port B, and port B wires are connected to port A. And I ask the students, we don't just do a startup, just verify proper operation, not a full-blown startup, but verify it. And what people do and this was for any multi-zone system, what they shouldn't do, but is what typically they do, is they run the whole system in heat, they run the whole system in cool. That works fine, all right? But listen to me. If you're installing any multi-zone system, it's easy to cross-pipe it, cross-wire, however you want to work at it. So verify one at a time. Turn the whole system. If it's summertime, put the whole system in cooling. Make sure that there's cool air coming out. You got a good delta T across the coil. And then satisfy one at a time, or turn one off one at a time. So when you go to unit A and you turn that off, that's the air temperature that should be getting warmer.
Yep.
When you go to unit B and turn it off, that's the one. If you go to unit C and you turn that off and unit C continues to blow out cold air, but unit D is blowing out warm air, then it's cross-wired or cross-pipe. Fix it, because you will. Because if you're doing this, if you're installing this in the heat of the summer or the cold of the winter, and when it comes time for a shoulder month and they're only using one and not the other, you will get a call back. And can you charge for that? No.
Not installation
So
mistake.
verify that the right port electrically and mechanically are connected the way that they should be. That's a big one.
One at a time. One at a time. Not turning the whole system on at once.
Yep.
You're not gonna find it that way. You got to turn on one indoor unit, verify refrigerant flow to it, verify proper operation, move on to the second unit.
And that's port style or branch box. And I'll tell you what, even one-to-ones. I had a call on time. Installers put 2 1-to-1 ductless units, right? Wall units, one on the first floor and one on the second floor, and the 2 outdoor units are right next to each other.
Oh, man.
And it worked fine all summer. And then it comes late August and September, and they say, it's not working right. And I found that the actual S1, S2, S3 wires, because they came down, through the line hide, the same one, they were actually connected to the wrong outdoor units. Right? So they cross-pipe 2 1-to-1. So just be careful of that. It's very easy to do. Just verify before you leave.
Yeah. And the nice thing about the Smart Multi, of course, when we're talking branch box even, it's MNet, right? So if we've got our maintenance tool converter, we can also hook up and verify any cross-wiring there as well, because we can look at coil temps.
All right.
So that's awesome. And then the last thing I just want to touch on really quick with branch boxes, at the outdoor unit, we have to flip switch 2, 5 on. And that's letting our outdoor unit know we're connected to a branch box. Remember that Smart Multi can both be connected to commercial heads
Very important
or a branch box. So at our outdoor unit, we got to let that unit know, hey, this is connected to a branch box. We're going to flip SW2-5 on.
All right. That's very important too.
Right.
All right.
Yeah. And if you don't do any of that, if you don't address, if you don't flip your port, SW1 port assignments on your branch box, will the system run? It will. But it'll malfunction. And the biggest giveaway is when you have an MHK2 that is locked in a wait screen and you can't get it out of a wait screen. Stop and look at your system. Make sure it's addressed properly, because that will cause communication errors with controllers. It's a big problem. We get a call all the time. My MHK2 won't come out of a wait screen. It's the controller, and they return the controller. And they just made a big mistake. It's not the controller. Take a look at your unit. Make sure it's addressed properly. There are no errors present, because it can affect multiple components.
I want to mention one more thing, too, before we move on to the R2. Right? If you have the branch box powered separately and not from B1 and B2 of the outdoor unit, make sure that that's powered before you apply power to the outdoor unit. If the indoor units have, and they have to be 3-pole switches. If you have a switch, if you're required by electrical code or your local inspector wants to see a switch at the indoor unit, it should be a 3-pole switch. It should break all 3. Right? Make sure that is on, in the on position, closed position before you power the outdoor unit. Make sure all the indoor units and the branch box are powered, and then power the outdoor unit. Otherwise, you will get communication errors.
Yep. That's one of the things I mention in class is if you have anything that interrupts, any switches, any branch box that interrupts power communication, we want to make sure those are in the on position before we flip our main disconnect, or else you will see that. Our units are going to see that communication right away. It's not even going to try to start. I
remember a handful of service calls back in the day when there was a communication issue and there was a fault, and that's what the fault was. And then I turn it on, everything seems to be working fine. And I noticed there's a wall unit there with a switch right next to it. And I asked the end user, did you happen to flip that switch? Oh, yeah, I'm not sure what it was. So I just flicked it real quick and nothing happened. It goes, well, you interrupted power. So now after that, I try to do it. Okay, is there a switch? Did anybody touch that switch? And it's, yeah, okay, just reset the outdoor unit and you're back in business. Because, there's a switch. What does it do? Yeah. All right, let's move on to the city multi-site. Let's talk about R2. All right. So there's still a branch box on the R2. So let's talk about what that does. So, Bryn, walk us through that.
Yeah, so similar to the residential, right? It's a distribution box. We can feed refrigerant to multiple indoor units from that branch controller. But big differences here is, remember, with commercial heads, we've got LEVs inside the indoor coils. So we don't necessarily need the LEVs to do the refrigerant distribution to each of our indoor coils. There are still LEVs in our branch controller, but they serve other functions. So with our R2 system, we have heat recovery. So the first thing that we do when we enter that branch controller is we hit a gas liquid separator, which is where all the magic happens, how we get that heat recovery.
Okay, let's talk about what heat recovery is for those that don't know.
Yeah, well, so heat recovery is mixed modes, right? It allows us to have continuous heating and cooling simultaneously at the same time.
So our largest system will take up to 50 indoor units. So I can have some of those units operating in heating and some operating in cooling. In a perfect world, capacity-wise, let's just say, for real easy, it's 10 tons. I know that you can't put 50 units on a 10-ton, but let's just say I have a 10-ton outdoor unit. If I have 5 tons of air handler in the heat mode and I have 5 tons of the air handlers in the cool mode, we're just taking the heat from the people who don't want it and giving it to the people who do. The very definition of heat recovery.
Yep, absolutely.
Actually, it's a very definition of refrigeration.
Yeah.
Is you take heat. Okay, so that's pretty cool. I've actually seen a maintenance tool file a couple of times that actually showed that. That's really cool.
I call that the unicorn.
Yeah.
Yep. Yeah. It's not always a perfect circumstance, but every once in a while you'll see it, and we're not using any of that outdoor coil for our condensing. Right. We're able to just send it all right back inside, bypassing that coil, and make our heat calls with that vapor from the cooling calls.
So now let's go back to that branch box. I'm the refrigerant, and I'm coming along. I'm leaving the outdoor unit.
Yep.
Right? And I go into the branch box, and the first thing I hit is what?
Our gas liquid separator.
Gas liquid separator.
Yeah, and it's a pretty simple design, but it allows us to send essentially a saturated refrigerant into that branch controller. And from that gas liquid separator, we're taking our vapor for all of our heat calls, our superheated vapor, and we're also taking our liquid. We're passing it through 2 tube-and-tube heat exchangers to further subcool that refrigerant before we send it to our cooling calls.
Yep. So saturated just means I have a liquid and a vapor existing together.
Yeah.
And you're right. It is quite simple. And I always compare this to a bottle of water.
Yep.
Right? If I put a hole in the bottom of a bottle of water, I'm going to get liquid coming out of it. If I take the cap off of a bottle of water and I can pressurize inside that, I'm going to have gas come out of the top of it.
Yep.
And that's what we do. We either send a superheated vapor or a subcooled liquid, depending on whether we need heat or cooling. And subcooling is important. I love asking the question in class, can we have refrigeration with 0 degrees of superheat? And I know we've had this before. We talked about superheat. Of course.
Yep.
Can I have refrigeration with 0 degrees of subcooling? No way. I need subcooling or there's no refrigeration.
Yep.
So the 2 tube-and-tube heat exchangers just make sure that I have a subcooled liquid going to those metering devices of each indoor unit.
Yep. Okay? Absolutely.
And if I want to connect, like we asked the question with a smart multi branch box, what if I want to connect a second branch box? How does that get connected? Do I tee off before I go to the first one, or how does that work?
Yeah, so if we're using sub-branch controllers, and with the N generation, we can use up to 11 sub-branch controllers now. We're entering the main branch controller, and there are outlets on the main branch controller for the sub-branch controllers. From there, we're just teeing off to each sub-branch controller off of a main line. So, our system is our two-pipe from the outdoor unit to the main branch controller, but we do need, because we don't have a gas-liquid separator in each sub-branch controller, we do need a hot gas line for units in heat. Yep. That's our third line on our main branch controller. So 3 lines out of the main branch controller to all the subs.
So a high pressure, a low pressure, and a hot gas line go in each sub.
Yes.
Yep.
All right. Beautiful. Yep. And then, Bryn, you mentioned that the LEVs are in the indoor units, unlike the M&P series. So what controls the flow of refrigerant now to the individual indoor units? So
when it comes to how we actually get the refrigerant out to those indoor coils, we have on one end of our refrigerant circuit a series of check valves. We call it a check valve block. And then on the other side is a solenoid valve block. So the check valve blocks make sure that we don't have liquid and vapor colliding, right? We can only go through one direction on each side. And then on the other end of our refrigerant circuit, we have a solenoid valve block. And that solenoid valve block has 3 ports, A, B, and C. And we kept it simple. Ports A and C are energized when we're in cooling, and port B is for heating, AC.
All right. That's pretty cool. So now, power, electrical power. How do I feed power to this branch box now?
This is going to be powered separate. We can't power our indoor or our branch controller or any of our indoor units off of the outdoor unit like we can with the residential.
And what's the voltage on those?
It's 208, 230 single phase.
208, 230 single phase, and that's it. There's nothing else. It's 208, 230 single phase fed from a separate circuit. You can't feed it from the outdoor unit.
Correct.
Yeah.
And then communication?
Well, communication is MNET, right? So it's 29 volts DC that starts at our outdoor unit, terminal block 3, and then we just daisy chain to our branch controllers, to all of our indoor units. If we're using an ME controller, those are also on the MNET.
Yep.
So
and it's a daisy chain. Just at the outdoor unit, go to the branch box in each indoor unit, and it doesn't matter what order we go in. It does. That's another misconception. It doesn't have to go to the branch box first.
Yep.
Steve, what about addressing?
So addressing is a little more involved with the city multi. It's not too bad, but we have some rules in place. Indoor units get an address range of 1 to 50. Outdoor units get an address range of 51 to 100. And branch controllers, same address range, but main branch controllers will get an address of 52 to 100. Possible address range on subs would be 53 to 100.
Okay.
So in lowest indoor unit dictates the address for the outdoor unit.
Right.
It's
and we cover the addressing quite extensively in our City Multi Essentials class. So if you're listening to this and you're like, hey, I'd like to know more, just sign up at one of our City Multi Essentials class. Look for our distributor locations. Some of them have the City Multi classes as well. If you're not near one of our 11 training centers, you can always have an option of going there as well. I don't want to turn this into an addressing episode because
it's so easy.
Yeah. There's one thing I want to point out though. We always say, well, it's very simple. It's very simple how we
everything
the system runs.
If you ask a brain surgeon, it's very simple operating that brain.
But
if you
behind the scenes, there's a strategy that the system needs to come up with. And that involves LEVs in the outdoor unit, LEVs in the branch controller, managing refrigerant to make all of this happen. And these LEVs are communicating with thermistors and calculating superheat and subcool and checking temperatures in and out of coils, in and out of the branch controller. There's a lot happening in the logic of these units to make all of this happen. It's easy for us to sit in class and say, yeah, it's simple. It just goes this way, goes that way. Well, how? There's a lot of strategy behind how we get this system to manage refrigerant properly to get our simultaneous heating and cooling.
Yeah,
Okay.
and when it comes to addressing too, all of our indoor coils on the commercial side actually have dials now, so they all get their own unique address.
Right. Unlike the M&P side, which don't have dials.
Right. And the other thing is we talked about with residential, if you don't address it may work, and then you might get that unknown error, communication error out of nowhere. With our city multi, you don't have nearly as much freedom. If you don't address that system, if you don't assign what port that indoor unit's connected to, you will more likely than not end up with an error code that you'll be chasing that.
And I was just going to ask you about, because there's addressing dials, so we need an address. But on the branch box for the smart multi, we tell the branch box what port to assign it to.
Yep.
But on the city multi, the indoor units have 3 dials. There's 2 dials for addressing, and there's 1 dial to tell it which port on that BC controller you physically piped it to. It has to know which port.
Yep.
Right. And what I like about those switches, and I always make sure that guys understand this, there are up to 16 ports on a largest BC controller. And so you need to identify, is it port 1 or is it port 16? But on the dials, on the face of the dials, it goes 1 through 9. Is it 10?
Yeah, 1 through 9.
Yeah, that's 1 through 9. That's right. And then it goes A, B, C, D. So A is 10 and B is 11. And if I'm going to put it on port 16, guess what? It stays on 0.
Yep.
All right. And the reason that we do that, imagine trying to get all those numbers in there, a second digit. It's a small dial. It'd be impossible to read. So that's why it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, and so on. All right.
And I'm kind of glad we keep everything kind of solid state on our end, because you hear a lot of other systems are auto addressing, but there's a lot of issues that come along with auto addressing. Yeah, our stuff, once you set it and forget it, it's that address for the rest of its life.
Yeah. Auto addressing there's an argument to be made, hey, it helps you out on the installation. But what I don't like about auto addressing is, and I'm going to digress here for a moment. We talk a lot about the DSB and having an as-built. I think an as-built should be left on the job site in the mechanical room for the guy doing the service, right? So if I go there to maintain or service this unit and there's an auto addressing, every time there's a power failure, it auto addresses again. By setting the addresses day one when you start this thing up, if it's address 1 today, it's address 1 tomorrow, it's address 1 next year, it's address 1 10 years, 20 years down the road. Nothing changes. So there's never trying to figure out which address is which, or which one's an error. So I think, to me, that's the biggest advantage to not using auto addressing.
Yeah.
And back to the branch box, just one thing I wanted to point out is that on the branch box needs to have power. If you don't have power to the branch controller, the system will not run. Everything will sit in there like it's satisfied, and you can go to any controller on the wall, try and turn it on, and that controller will go right back to the off mode.
Yep.
Now, with maintenance tool being updated the way it is, it tells us when there's a power outage. In the past, you'd have to grab a beater, get up there, and
in the past, before maintenance tool had that feature on there, that would be the most common call that we'd get is, hey, nothing runs. I send a command to it and it just goes back to off, right? And hey, check the power at the BC controller. We even had a video on that on the Ella Madison one on my link drive just for that. But now it will tell you. So a couple more things. We asked these questions about the Smart Multi-Branch Box, so let's make sure we cover it here. Steve, is there a condensate drain on the R2 BC controller?
There is, yeah. So you'll have some condensate, and depends on where that branch controller is mounted. If it's in a very humid location, there could be some condensate, and we have a drain pan for each, either whether it's the main or the sub branch controllers. And one of the other thing I wanted to point out was make sure that you're ordering the correct branch controller models.
Yep.
There are different models. There's a branch controller main, a branch controller single. So if you're ordering a system and you plan on putting sub branch controllers, you have to make sure you order the correct model main branch controller, because you'll find out real quick if you order a single, you're not going to have connections to feed your sub branch controllers on the other end.
So let's review that now, because that's important. We have 3 kinds of BC controllers. We have a main, we have a single, and we have a sub. If I have a single that speaks for itself, it's what its name is, I can only have one BC controller and that's it. I cannot have a sub. If I need, I can't have a sub by itself either. The only way I can have a sub is if I have a main.
Yep.
So you can order a main and not use a sub.
Mm-hmm.
You can order a single and you can only use a single. And if you need a sub, you need to have a main first.
Yep.
And then,
Now, why would you use a single? Basically, you have a small system, and you're maybe using a maximum of 16 indoor units, and that's it. You don't need any subs.
And I know I'm never going to expand. I'm never going to change it.
Yep.
You know,
realistically, design-wise, there's no difference between a BC main and a BC single, with the exception of not having our 3 ports coming
three
out
lines.
to go to a sub.
All right.
But everything engineering-wise is the same inside.
Yep.
It do the same thing. We still have our heat recovery. We just don't get those 3 ports to go to a sub.
One last question, Steve, on the R2 BC controller. Can I mount it in multiple positions? Can I mount it on a wall? Can I mount it upside down?
Unlike the residential branch box, you cannot mount the commercial branch controllers in any position. There's only one way to set that up, and that's upright in a horizontal application.
Right.
Usually always suspended by threaded rod.
Yep.
Right.
We're going to completely lose the function of our gas liquid separator if we mount that any other
Right.
any other orientation.
And not to mention there's a condensate pan in there too. All right. So is there anything else that we need to cover on the R2 BC controller?
No, I think that pretty much squares it away. I mean, there's always going to be questions, right?
Right.
So attending the class will get you a more full understanding.
Come to the City Multi Essentials class. You'll get a full understanding of it. We go through that in detail. If you have any questions for us or any topic ideas, Steve, what's our email?
METUS Tech Show at hvac.mea.com.
Okay. All right, so that does it for that. Let's move on to the hybrid VRF system, which has a hybrid BC, a hybrid branch controller. So real quick, a high level, what is a hybrid VRF?
So our hybrid VRF works exactly the same as our traditional heat recovery VRF system, but we're actually using water as our heat exchange medium, where we have refrigerant to water plate heat exchangers inside that HBC. In order for us to have both heating and cooling simultaneously, we actually have 2 reversing valves inside of that HBC. But everything beyond that refrigerant side is all water. So we follow the same typical, hydronic rules when it comes to our indoor coils and everything. But
Same addressing rules.
Yep.
Except there's 2 pumps inside the HBC and 2 heat exchangers.
Okay, so let's back up a minute.
Sure.
We got the same outdoor unit that we use for the R2, right? Nothing changes there. So as far as the wiring, as far as the MNET, as far as the refrigerant piping, maximum length, and all that stuff, nothing changes. We take 2 pipes, a high and a low side pipe. We go from the outdoor unit with refrigerant, and we come to the HBC, the hybrid branch controller.
Yep.
And there's heat exchangers in there. And now going to each individual indoor unit, there's no longer refrigerant. So if we put this HBC, this hybrid branch controller, in a mechanical room, that refrigerant never goes anywhere else. It's either in the outdoor unit or in the branch controller or in the piping in between. It never sees the indoor units. And we had a podcast on the HVRF. I don't need to go there, but it's we did one on that, and enough on that. So let's just talk about the branch box itself. So now, and you guys mentioned that one of you said there's a pump in there and a couple of pumps and reversing valves. So let's talk about just the water side now. Let's not talk about the refrigerant side other than the heat exchanger. So walk through that, Bryn.
So it's pretty simple. I mean, when it comes to the refrigerant side, it's literally just going into a plate heat exchanger and out. There's 2 of them. But when it comes to the water side, we're basically using water pipe. We have both rehow, and we also have copper that you can use to pipe to our indoor coils. Indoor coils look the same profile, where they're just a water coil now instead of having a refrigerant-based coil. The same rules of a hydronic supply. We need air elimination. We need a purge setup. But because of the fact that it is a water HBC now, right? There's water in 95% of that HBC. we give you some components that you would normally have to put on a hydronic system. It comes with a pressure relief valve in there. It has 2 bleeder valves on the HBC that allows you to purge air through the system. So there's a couple built in, your pumps you mentioned. So we actually have pretty much everything you need to get that system. All we're really doing is putting in some air elimination in our piping and then a purge setup so we can purge air when we need it.
All right.
Yeah, just think of it like a low pressure boiler system. It's got an expansion tank, runs at low pressure, like 12 psi through the water side, and you can have a water feeder system, or you could have just constant regulated water into the system. Pretty cool stuff.
All right.
I'm excited
Good
for this system.
So we're in the process of putting together a hybrid VRF training class. And there's going to be the prerequisite because everything on the VRF side stays the same. If you're already doing VRF, you'll know it'll easy to switch over to hybrid VRF. Mm-hmm. So there'll be a prerequisite for this class. You have to take the 3-day City Multi Essentials class first. If you've done that, you'll be able to take the hybrid VRF class, which right now we're building up. It looks like it's going to be 2 days. So look for that class and look to attend it because in that class, on the startup is going to be now we have to worry about the water side of it too.
Yep.
We're still talking about DSB and all the addressing, grouping, MNet, everything stays the same. But now there are 2 procedures that we have to go through on the startup. So we don't have to go through and walk through them, but basically in a high level, what are those 2 procedures we have for water that we don't have on the R2?
So essentially we need to get the debris out of there, right? We just hooked up a bunch of copper pipe and similar to even with refrigerant, we may deburr, we may have to clean up that pipe. We want to make sure that we catch any debris. So we'll run that system, we'll open up all of our valves, and we have 2 strainers built into that HBC that after we go through our debris removal process, we're actually going to drop those strainers and we'll find sometimes it's Teflon tape, sometimes it's copper shavings, just the things that can get built up. And we want to catch those before we're running this system full time and potentially damaging the pumps. So we have to go through that process. Once we've done that, we've cleaned out our strainers. Now we can go into the air elimination process, which we flip a couple dip switches. We start doing our air elimination. It'll tell us it takes between 140 and 280 minutes to do that. We open up our air bleeders. We let the thing run. And same basic principles. It opens up all of our valves. We just make sure we purge all that air. Our control board has an LED screen just like our outdoor units. It tells us when it's done. We can close up all of our valves, and now we're good to go.
All right. And then and that's it, right?
Yeah. The other thing to mention that I like about this unit as well is the only place that refrigerant exists is in that HBC. So we still have the ability to hook up subs. We still have sub BCs for the hybrid VRF, but no refrigerant goes into those subs.
All right.
So it's just water.
That's good to know.
Yeah.
And then let's talk about power. How does it get power and what is that power?
Same with the R2, right? So it's still 208, 230, single phase, powered separate.
And it still needs MNet and it still needs addressing.
Absolutely.
Okay. And just like with the R2 BC controller, the hybrid BC can only be mounted one way because it does have a condensate pan.
Not even just a condensate, but that's our drain pan as well. So if our pressure relief were to let go for whatever reason, that water is going to collect in that drain pan. So we do still have drain ports that we have to hook up PVC or run our drainage for.
All right. So that I think about does it for branch boxes. If you want more information on the hybrid VRF, you can go. We did a podcast on it a while back on HVRF, and there's a class coming, so look for that. And it might already be out by the time, because we're recording this. We don't know when we're going to release this, so it may already be out. But as of right now, of the recording of this podcast, it's not. We're working on it. Anything else, Steve? I'll give you the last word.
No, that's about it. Follow your install manual at all times. Use Diamond System Builder.
Yeah.
Check out mylinkdrive.com for all your information on any branch boxes, including the HBC or hybrid branch controller.
All right. Yeah. Well, thank you, everyone.
Yeah.
Thanks, guys.
I think I'm going to go ahead.
Go ahead.
I think I'm going to go make some waffles.
No, you know what, Steve? We're talking about breakfast.
Waffles. I love waffles.
Listen, but you know what? But the one thing we forgot to talk about in the beginning is, you know what I really love? It's just simple. I love the Chick-fil-A chicken biscuit for breakfast.
It is. It's good. I think Chick-fil-A gets way too much hype.
What? No,
but
I love Chick-fil-A.
to each his own.
Yeah, I mean, it beats me.
You know what's even better? You know what's even better than that? Chicken and waffles from Hash House at Go Go.
See, I just can't get the chicken and waffles. It just doesn't appeal to me.
It's the best.
All right.
The only thing I don't like about it is not big enough there. Yeah. Not a large enough portion.
Yeah. Well, it is lunchtime, and I think I'm going to go find me some breakfast somewhere. I think Bryn, waffles.
Moro's.
Okay.
Moro's right down the street.
Yeah.
Main Street Skillet.
Go there. Oh, that Main Street Skillet. Oh, that's so good.
Oh, yeah.
Whatever the biggest thing on the menu is.
Yeah. All right, guys.
All right.
Take care.
See you, Steve.
See you on the next one.